This Zoom session is being brought to you by the Fractal Cybernetic. Okay, for today, we do section 1.3 about functions and also a couple other related things, difference quotients. All right, fine. A function. You know, I like to describe this as more like mathematical grammar than mathematical vocabulary. It's more about how we say things and what specifically we'll be saying here in trig class. But a function, it's basically a rule that takes an input called x and yields an output called f of x. All right. So, Stephen Wilson. It's denoted f parent x n parent, f of x. So you can think of x as a box. You put x in the box, out comes f of x. This calculator is a box full of functions. Now, the set of all possible inputs of f is called the domain of f. Set of all outputs of f is called the range of f. You find f of x by substitution and evaluation. For example, here f of x equals 3x squared plus 2x minus 4. What's f of 0? What's f of 1? What's f of negative 1? Okay, plugging 0 in for x, get 3 times 0 squared plus twice 0 minus 4. After some arithmetic, you get negative 4. F of 1 is 3 times 1 squared plus 2 times 1 minus 4. Arithmetic gives you 1. F of negative 1 is 3 times negative 1 squared plus twice negative 1 minus 4. That gets you negative 3. All right. Let's see. The graph of a function. Well, it's a set of points with coordinates x by f of x. So if you go over a distance x and up a distance f of x, this point f by f of x is a point on the graph of a function. Since f of x is a single value for any given x, that means the vertical line will meet the graph of the function at most once. That's called the vertical line test. For example, this line, this curve here is a function graph because every vertical line meets it once. This is not a function graph because here's a vertical line that meets it 3 times. If you take the graph of a function here on the plane and you project it down to the x-axis, the shadow projected is the domain of f because it's the possible inputs. If you project it horizontally onto the y-axis, the shadow thus projected is the set of possible outputs or the range of f. So this is how you can see the range and domain of a function. The domain is everywhere where f of x is defined, and that'll mean generally no division by 0 because you can't divide 1 over 0 and 0 over 0 properly, and no square roots of negatives for much the same reason. Although later on we will talk about what are called complex numbers, where we can define square roots of negatives. You have to basically add another dimension to the numbers. So instead of a number line, you get a number plane. But we'll get to that later. So, for example, here's a function 1 over x squared minus 9. What's its domain? Here's the function root of x minus 5. What's its domain? Okay, for this one, 1 over x squared minus 9, the domain is where the denominator is not 0. So x squared minus 9 is not 0. It's everywhere but plus or minus 3. So it's this doubly punctured line. Here, g of x is root of x minus 5. So, okay, here I'm using g for the function name rather than f. All right, so this is defined when this x minus 5 inside the square root is at least 0. So that means x greater than or equal to 5. So everything including 5 and above is the domain of this function g. Now, here's something that you'll be seeing a lot of when you get to the calculus, something called the difference quotient. Here's the point x by f of x, move over a distance h to x plus h and move up to back to the graph. So this is the point x plus h by f of x plus h. If you join the two lines, the points, you get a line, and the line equals the slope. The slope of the line is what's called the difference quotient. The slope will be rise divided by run. Rise is f of x plus h minus f of x. The run is x plus h minus x, or in other words, h. So the slope, the difference quotient, is f of x plus h minus f of x, that divided by h. When you get to the calculus, we'll call it delta F over delta X. The delta, this triangle is Greek letter D. It means the change, the difference. So the difference of the x's divided by the difference of the x's, change of F divided by the change of X. It's a slope. Later see it's related to things like velocity and such. Okay, now here's some examples from the book. And yes, as I mentioned before, these odd numbers are obsolete, referring to a previous edition. Okay, so some questions. Is the cube root of x a function? The answer is yes. For every x you input, this is definable, even for negative values of x. Is 2x squared plus 3y squared equals 1? Is the graph of that a function? No, the answer is no. You can set x equal to 0, then two values of y's will work. 0 by 1 over root 3 and 0 by negative 1 over root 3. So here's a value of x, 0, and two values of y. And both of these points are on the graph. And therefore, it fails the vertical line test and is not a graph of a function. It's actually a graph of an ellipse. Let's see, I think we mentioned that before. Here a function 3x squared plus 2x plus 4. And let's ask what's f of negative x, what's negative f of x, what's f of x plus 1, what's f of 2x, what's f of x plus h. Notice here, we're taking negative and then f, here we're taking f and then negative. So we're asking whether the order of operations matters, and it turns out that it does. F of negative x, you put a negative x in here, 3 times negative x quantity squared, plus twice the negative x plus 4. After a bit of work, it's 3x squared minus 2x plus 4. Negative f of x is the opposite of this, 3x squared plus 2x plus 4. Negative 3x squared minus 2x minus 4. Notice that these are not the same. The linear term, minus 2x, is the same, but the quadratic term, they're opposite, and the constant terms are opposite. So order of operations counts. We proceed. F of x plus 1 is what? Well, 3 times x plus 1 squared plus x plus 1 plus 4. That'll do. We could have, of course, expanded this, but no point in bothering right now. Similarly, f of x plus h is 3 times x plus h squared plus twice x plus h. That plus 4, and there we go. Same as this when h equals 1. F of 2x, you put a 2x in here, 3 times the square of 2x plus twice 2x plus 4. After a bit of work, that's 12x squared plus 4x plus 4. All right. Excuse me for a moment. Here we have a function, x over x squared minus 16. Sorry, that looks too much like a plus. Okay, for the domain, this needs to be defined. The only potential problem is this division signs, and there's no division by 0. So x squared minus 16 is not 0, which is true everywhere except plus and minus 4. So x is not plus or minus 4. It's everywhere on the line except these 2 points. Here we have, let's find out what the difference quotient is for this function. F of x equals 4x plus 3. So delta f over delta x, the change in f over the change in x, f of x plus h minus f of x over h. Plugging f of x plus h here, you get 4x plus h plus 3 minus, this is 4x plus 3, all divided by h. Okay, so you distribute this 4, you distribute this minus 4x plus 4h plus 3 minus 4x minus 3. 4x's cancels, 3's cancel. 4h over h, which comes out to be 4. So in other words, this is a straight line graph with a constant slope of 4. Here we have the rather gnarly looking function, 2x over x plus 3, find its difference quotient. Okay, delta f over delta x. Okay, 1 over h times f of x plus h minus f of x. I'm putting this 1 over h out in front and keeping it there because it's just a little bit more convenient to write it that way. So f of x plus h, twice x plus h over x plus h plus 3 minus f of x, that's 2x over x plus 3. And okay, we do a bit of fraction arithmetic. Yes?
25 years we've been designing and building the finest putting greens and lawns.
Somebody seems to be Paolo, I believe your microphone is on.
That was me, and I'm disgusting, but it's just me, I'm disgusting.
All right, never mind. All right, so we expand this, get a bunch of terms, most of them cancel. After a bunch of work, you get 1 over h times 6h over x plus h plus 3 times x plus 3. The h's cancel. That sort of thing actually usually happens in a difference quotient. And here we get 6 over the product of x plus h plus 3 with x plus 3. Here we have a graph. Actually, you'll see this graph later. This is a graph of one cycle of the cosine function. Is the function graph, what's the domain, what's the range, what are the x and y intercepts, and does it have any symmetry?
Professor,
Yes.
one question before we get into number 83. So the previous problem, the delta f over delta x, that's the formula
The
for
difference quotient, yes.
the difference quotient. Okay. And then, all right, the fx, okay, x
F
plus
of
8.
x is 2x over x plus 3. You put
Okay.
here, here's f of x plus h. You put here, you're putting an x plus h wherever the x is. Then
Mhm.
that difference times 1 over h. We add or subtract two fractions by cross multiplying, and you get this complicated expression, and you expand all this, and most of the terms cancel, and you get this,
Okay.
this times this, and the h's cancel. That's
Mhm.
what we get.
Okay, thank you. Just double checking.
No problem, no problem. Here we have, okay, here's a graph. It's a graph of the cosine function. Is it a function graph? Yes. Every vertical line meets this graph once. What's the domain? The domain is if you project it down to the x-axis, it's from negative pi to pi. If you project, and for the range, you project this onto the y-axis, and y is between -1 and 1. X-intercepts are here and here. It intercepts the x-axis here at negative pi over 2, and y-intercept is here where it meets the y-axis at y equals 1. Yeah, and this is symmetric around the y-axis. You flip left for right, you get the same graph. Well, let's stop for now.